Welcome to this video, guys. In this video, I'll show you how you can Dockerize this Python app using secure ChainGuard images and how you can share this or any of your other projects with your friends or the world by deploying it to Google Cloud. While containerization offers many benefits for deploying Python applications or any other application for that matter, there are some key challenges when it comes to security. Here are some points to consider. The first is hidden vulnerabilities in dependencies. Using traditional container images often means relying on large complex base images that can contain hidden vulnerabilities. These vulnerabilities arise from unnecessary components, outdated packages, and lack of transparency in software supply chain. For example, in 2017, a critical vulnerability in the popular Python library Equinox exposed many containerized applications to remote code execution attacks. Since many developers might not be aware of this vulnerability in their dependencies, their application remained at risk. The second one is lack of transparency. Traditional container images can be opaque. You might not have a clear view of exactly what's inside the container, all the components, libraries, and configuration. This makes it difficult to identify potential security risks or outdated dependencies. And finally, there's the risk of image tampering. Container images can be tampered during build process or even after deployment. Malicious attackers could inject vulnerabilities or steal sensitive data if proper security measures aren't in place. Now let's discuss some solutions to these problems, one of which we will be using in this tutorial too. So to get rid of hidden vulnerabilities, what we can do is we can use base images provided by ChainGuard that are minimized, hardened, and periodically patched. The word ChainGuard uses to describe these images is distroless, which means they contain only an application and its runtime dependencies with all the unnecessary packages removed, hence eliminating the vulnerabilities affecting these packages. In addition, the packages included in ChainGuard images are patched daily as per the documentation to make sure they are completely up to date and contain all available security patches. To solve lack of transparency, we can generate SBOMs, that is Software Bill of Materials. ChainGuard provides complete transparency into the content of your container images. You can see exactly what libraries and versions are included, allowing you to identify outdated components or potential security concerns. Regarding image tampering risks, ChainGuard allows you to sign your container images. This signature acts like a digital fingerprint, ensuring the integrity of the image. Any modification to the image will invalidate the signature, alerting you to potential tampering. I'll provide some material at the end of the video to look into this further. So let's jump into the code and have some fun. Within a few minutes, we will have run a container that uses ChainGuard's base image for Python, and that runs a Python app that prints a simple hello world. So I'll go to File, Open Folder, and we will create a new folder. And you can create the folder anywhere you want. I'll just call this my app and select the folder. And let's create a file called main.py that will house our Python code. So let's just create a function and we will just print hello world in this function. Now, this basically means that this main function will be called whenever we directly run this file. So if we import this main.py, this function will not be called. This is what this name equals to main is doing here. Now practically, this is similar to writing just print hello world. So if I remove everything and just write print hello world, it will do the same thing. But this follows a better structure and it's more organized and it's more expandable. So this is what we are doing. And if I run this, it will just print hello world. Now let's Dockerize this using ChainGuard's base image for Python. If you go to this URL, I'll have this link in the description below too. And you scroll down a bit, you'll see there are images for Go, Node, PHP, Python, Nginx, JDK, and a lot more. These are the popular ones. So I'll click on Python. And this is the image that we will be using. So I'll copy this. Let's go back to our project and let's create a Docker file. And here we will write from and the link that we just copied. Let's create a work directory. We'll call it app and we'll just copy our main.py file into the work directory. And let's set the entry point for this container. Now this means that this is the command that will be used to run the container. Full path of our script, that is app/main.py. So inside app, we have copied our file main.py, hence this is the path. So this is basically saying, if I do this, As you can see, we use Python and then the path of the file. And basically this is the same thing. Inside the container, we will run Python and then the path of main.py, and hello world should be printed. So let's try it out here. Now open the terminal and build the new image. So the command is docker build -t for tagging the image, and we will just call this, let's just say hello world. And then the Docker file is in this directory, hence we have this period here. Hit enter. And as you can see, the build is complete in less than a minute. And now let's run this. So hello world will be run, and this rm means once the container is stopped, just delete the container so that it does not take any additional space. So let's run this. My mistake here, guys, we need to add double dash, not just single dash. I'll add one here, and let's run this again. So as you can see, hello world is printed and we have exited from our container. Now if I check Docker Hub here, Docker Desktop, and I click on images, as you can see, our image is created and its size is just 64.06 MB. So it's much smaller than the latest Python image. If we have directly used Python image instead of the ChainGuard one, it would be at least a few hundred MBs. So this is one of the benefits of using ChainGuard's images. They are slim, hardened, and they do not contain any unnecessary packages. Now let's see how we can Dockerize a real-world Python application and how we can deploy it to Google Cloud. So this is our Python application. Let's first run this and see what it does, and then I'll go over the code and just give you an overview of what we are doing here. So I'll go to terminal and just run it using python run.py. Okay, so we have not installed the dependencies, so we will use pip to install those. And all the requirements are inside this requirements.txt file. Let's wait till this is installed. Also, I'll have this in GitHub, so you can check the link in the description if you want to see the code. Okay, so the dependencies are installed. Now let's run this again. Okay, so control and click on this application. Click on this link to see the application, and this is our application. Okay, so first we will register because we don't have a user yet, and I'll just register as vishal@vishal.com, and let's give a simple password. Okay, the user is now registered. Let's log in. And now I have logged in. Let's create a new to-do list. I'll call it create tutorial, description test. Click save here, and we have our to-do list. Let's add on. Okay, buy groceries. Okay, so we have two to-do lists. Let's see what we can do. Edit. We can set this as completed, and we can delete tasks. Okay, so it's basically a to-do list where we can register, login, create task list, edit, and delete tasks. So let's see a code overview and let's see how we are doing what we are doing here. So first we have this run.py, and basically this is just running our application. We are importing create app from to-do_app module and creating a new instance of create app, and then we are just running it. Inside our to-do app, okay, first of all, if you have noticed, this instance folder is automatically created, and this is because our SQLite database is created whenever we run this app. So it does not matter even if we delete this, because in the next run it will automatically create it. But keep in mind that if you are using SQLite, if you delete this, all the data will also be deleted, and in the next run you will have to create everything again. Okay, so inside our to-do app we have auth views and to-do views. These are actually functions of how we are handling stuff. So basically you can think of this like controller. So first in auth views we have a register function that is handling the register, and then we have login function which is handling the login, and we have two functions here that runs on every request that checks if a user is logged in, and then we also have a logout function. So basically login, logout, and register is handled by this auth_views. And then we have to do views, and this just has the list functionality, create functionality, update, and finally delete functionality for our to-dos. And besides these two, we have just two models. That is, these are the tables that will be created in our database. Now for this project, we are just using SQLite. For a real project that you will deploy, you'd much rather use a database like MySQL or PostgreSQL or something else. Okay, and then we have init.py. So this basically initializes our application. What we're doing here is we are setting up our database, we are initializing the app, and we are registering the views, and we are returning app. So whenever we import create app, this init.py will be executed, and we are returning app, that is the app object, when we initialize our create app inside our run.py. And we have views inside our templates, and we have our CSS and images inside our assets folder. So basically this is a pretty simple Flask application. And yeah, if you have any questions, you can ask me in the comments below. Also, as I mentioned earlier, this whole project is available in GitHub, so you can just clone it and play with this yourself. Okay, so now we have our application, we have run this. How can we Dockerize this? Or more specifically, how can we Dockerize this using Python image from ChainGuard? Let's go back to the first project that we created here, that is the simple Hello World Python app, and let's inspect its Docker file. Here we have a base image, and we are just running our application. In this project, what we will use is something called multi-stage Docker builds. So we use this because traditional single-stage builds include the entire development environment, like build tools like pip alongside your application code. It creates somewhat bulky images. Multi-stage builds address this by separating the build process into stages. Multi-stage approach results in much smaller final container image, which benefits deployment in several ways, including faster downloads, reduced storage costs, and improved security due to less attack surface. So let's get started by creating a new Docker file. Let's check the type of images available in ChainGuard's official website. And here, if you scroll down a bit, you will notice there are two kinds of images. There is latest dev and latest. So how are these different? Now, if you read here, latest dev is a variant that contains a shell and a pip. So we will use pip to install our dependencies, and then we will use this base image, that is the slimmer and the one that does not contain pip and shell, and we will copy over the installed dependencies from this one to this one. So let's see how it looks like. We will copy everything inside this application, excluding the Docker file, to our container. So what I'll do is I'll create a new folder called app, and I'll move, okay, not here, I'll make it outside in the root directory. So let's do this, and let's create a new folder, let's call it app, and I'll move everything inside this app folder, run.py also, and finally requirements.txt too. So now we just have a Docker file here, and then we have our app here. So in the Docker file now, let's create a first stage, that is stage 1, and we'll call it the builder stage. Here we'll use the image that contains pip. Which one was that image? The dev one, right? So I'll copy this and use it as builder. You can name this anything you want. And I'll create a new work directory inside our container, call it /app, and we'll copy our requirements, that is inside our app folder, right? So inside our app, we have our requirements.txt. We'll copy it inside our Docker container, and we will create a new virtual environment inside our container, and we will install the dependencies. Not install it, we will activate the virtual environment first. After activating the virtual environment, what we'll do, we will install the dependency that we have copied, right? After this, we have stage 2. So we've used this latest-dev image that contains pip and a shell to install our requirements. Now we will use a much slimmer version, that is the that is this one. So this does not contain shell and a pip, so we will use this one now. And again, inside this also we will create a work directory, and we'll copy our application code, that is everything inside here, to the current directory, that is the app directory inside the container. And what we'll do is we'll copy whatever we have installed here, the dependencies. So to do that, what you do is copy -- from builder to app/.env. So this is what we are copying from builder, this one, to this new folder inside our app directory in the container. Now we have our code ready and we have copied the dependencies. Let's see if we can run it now. So we'll set the entry point. Again, it is very similar to the entry point that we had created in the first Hello World project, but this time, instead of running the base Python, what we do is we will run Python from our virtual environment. The code is .env/bin/python, comma, our run.py. So since we have copied everything inside our current directory here, and the current directory is app, so we don't need to do anything. We can just do run.py. Okay, now this should work. Let's see if we can build an image from this. So we will do docker build, and let's call this to do image. Hit enter, and let's see if it works or not. So yeah, I'm getting this error that says docker daemon not running. So my docker has stopped. Let's run this again. Let's wait till it has started. Once it has started, I'll minimize this and try to build the image again. Okay, I'm getting an error that says from builder. Where is it? Okay, so it's not a dash here. It's the name that we have given to this stage, that is builder. So it's equals to, not dash here. My bad. Let's try to save it and run this again. Okay, now we have our image ready. Let's try to run it. So keep in mind that we have ports, that is 5000 listening inside our container, right? So our application is running on port 5000. So we will publish 5000 port inside our application, and we will map port 5000 in the host to our container. And let's give this a name. Let's say to do container. And what was our image name? Image name was to do -image. So I'll write to do -img. Hit enter. Okay, so the first thing here is not to do -container. We need to define this here. So name of our container is to do -container, and we will be using this image to run this container. Now let's run this again. Let's again control click on this link to see if this is working. And yeah, if I do login, let's see if it works, because I don't have a user here. It should give me an authentication error. And it does. So let's register. And the registration was successful. Let's log in and see if everything is working well. And everything is working as expected. Now we can create task, edit task, and delete task as we have seen previously. Now that we have Dockerized our application, let's see how we can deploy this to Google Cloud so that everyone can see it and we can access this from a public URL. The process is pretty simple. We will push our image to Google Artifact Registry, and then we will run the image using Google Cloud Run. First, go to this URL. Again, this is also in the description below. You can just click on it. And if you've not logged in, just log in. And then what you can do is click on this button here and create a new project. Just give it a name and click on create. For me, I already have project created, so I'll just switch to that project. Once you have created a project or selected a project, search for Artifact Registry, and you will see this here. Click on this and click on enable. It will take a few seconds to enable this. And once this is enabled, you will see something like this. Now we will have to create a new repository, and we will do that later. And after this is done, search for Cloud Run and click on this. And see, in my case, it is already activated. If this is not activated in your case, just click on the activate button as we did for Artifact Registry. So now that we have enabled the required services, we will go to artifact registry again, and we will create a new repository where we will push our code. Sorry, we will push our image. So click on create repository. We will be using Docker. The mode is standard and location is regional. You can choose multi-regional for your production environments. For now, I will just choose North America - Northeast 1. You can have a description here. I'll just write tutorial, and you can leave these as it is. No need to enable any of these things, and just click on create. Okay, it seems I have forgot to give it a name, so I'll give it a name. Let's just say chain dev and click on create. Okay, so name should be lowercase. I'll just call it chain_dev. Okay, no _2. So just give this a name, chain dev or whatever you want, and click on create. And finally, our repository is being created. Okay, so we have our repository ready. So this is the repository that we will use to push our image to, and then we will run this image using Cloud Run. Now let's push our local Docker image to the artifact registry. First, we need to rename our image so that it contains all the details required by artifact registry to know where to keep that image. So this is the image name format that we want to use. Now before this image name, this is the region that we had selected our repository for, and this is the project name, this is the repo name, and this is the image name. Okay, so let's rename it. First, open command prompt or terminal, and let's check our current image name. And to rename this image, that is -image, you can just do docker tag and then the current image name, that is -img, and then the name that we want to change this to. So if I go back to my Google Cloud here, and this is the region, North America - Northeast 1. So you can copy it and after your region, we need to have docker.pkg.dev and then your project. The project is this, so you can just type this, and after this you need to have your repo name, that is chain dev, and then finally you can give it any name you want. I'll just give it to-img. Hit enter, and now you have renamed your Docker image to the required format. Now we will use gcloud SDK to configure the repository and authentication. So if you don't have gcloud installed, it is an SDK provided by Google to manage your Google Cloud resources. You can just follow this guide and install it, and I'll have this link in the description. It will show you how you can install gcloud. Okay, after you have installed gcloud, you just run this command, gcloud auth configure docker, and your docker, basically this part here. So I'll copy this, enter it here, and hit enter. So this will now manage authentication and everything. As you can see, it is now showing the message gcloud credential helpers already registered correctly, because I had already done it. In your case, these details will be entered. So once you have configured the authentication, you can now push your image. So just write docker push and then your image name. All the details regarding where to push and which repository to push to are in this name. So you can just enter this command here and hit enter. So as you can see now, we are pushing our image to repository and we are done. Let's check if our image is here. So I'll go inside this repository, and as you can see, the image is now here. Now let's run this image using Google Cloud Run. Here you can search Cloud Run and click on this, or you can just click on this navigation menu button here and scroll down to get to Cloud Run. Here click on create new service and select the image that we have just uploaded. And now service name is automatically generated. You can change this to do whatever you want. And for region, you can choose any region that is closer to you, but I'll just choose this Montreal one because this is the one where our Docker image is. And for now, I will choose allow unauthenticated invocations so that anyone can access our to-do app. Here, you can increase the number of instances, and this means that if there is more traffic, your service will auto scale accordingly. And now you can just click on create, If you want, you can click on this to see your container details, container ports, and so on. We want to send traffic to port 5000 because our app is listening on 5000 if you remember. And for the rest, container command, you don't need to enter this for now because we have set an entry point in our Docker file and that entry point will be used. And additionally here, you can choose memory and CPU that you want to allocate to your instance. Now you can just click on create and it will take a few seconds to load up. Once this is done setting up, you'll see this URL here and you can copy this or just click on this and it will open in a new tab. And you can now access your Python app from this URL. So congratulations guys, you have Dockerized your Python app successfully, and now you can share this URL with your friends and yeah, have fun. Now let's look into a few more topics that will help you with security and consistency. SBOMs or software bill of materials serve as a detailed inventory of all software components within your container image. They include your code, libraries, offering complete transparency into the image's content. This transparency is crucial for identifying potential security risks early on. With SBOMs, you gain the ability to track dependencies, their versions, pinpoint outdated or vulnerable components, and ensure consistency across various deployments. Next, there is image signing, which provides verifiable integrity for your container images. This means that you can verify that the image you deploy is exactly the same as what was built without any unauthorized modifications. Moreover, image signing enhances trust and traceability by helping you establish the authenticity and origin of your images. This is crucial for maintaining a secure and reliable software supply chain. For more information and resources on implementing SBOMs and image signing in your container workflow, check out the link in the description below. Thank you for watching. If this video helped you, click that like and subscribe button. If you have any questions, let me know in the comments below.